There's actually sort of two parts to today. That's one of them. The other part is we're going to examine some questions that you kind of know how to do from yesterday, most of them at least. But we're going to look at them in a sort of more like a deeper kind of way. So one question we're going to do 3 different times in 3 different ways. And the whole point is because different people like to solve these things different ways. So we'll show possible ways that you can solve these things, and you will pick your favorite, and kind of you can do every question that way, right? So it's not like you need, like we're going to do method 1, method 2, method 3, but you don't need to memorize each method. They're not formal methods that you need to know or anything like that, okay? So part of it is just looking at optional ways of solving these things, but another part for me is this is when, like again, we're getting closer to the end of grade 10. Grade 10's a big year. You start learning all these really important skills that are like the foundations of higher mathematics, like factoring, okay? Like some of the formulas that we did, like solving a linear system or solving systems in general. Okay, these are big skills. And yes, they get more complicated in higher grades, but we introduce them in grade 10. That's why it's such a big year. So by now, you've become much stronger mathematics students, right? Like what you know now compared to what you knew when you came into this class is huge. And so it's a nice opportunity to look back and start looking deeper on mathematical connections and how, and like just take a deeper look at how different things are related. And so it's really neat. Like there's sort of big picture stuff here. Don't let it overwhelm you. Don't let it be like, oh my gosh, I don't understand what he's doing. Why is he doing all these different things? Or why are we doing all these different things? It's about thinking. It's a thinking exercise and making connection between different methods of solving and different skills, and how there are all these different skills we have in mathematics. If we use them in different ways at different times, solve problems in different ways, always get to the same solution. Like there's a lot of things going on. So make your own connections to it. Okay, come up with your own way of connecting to it. But ultimately, you have to be able to solve these problems. You don't have to be able to solve them 3 different ways. So if you feel like you're getting overwhelmed, remind yourself, hey, I can solve, I like the first method. I can do it that way, so I'm good. And the rest of it is kind of a thinking exercise. I hope that makes some sense as we get started. That's going to be the first handful of questions are going to be like, different ways of solving these things and looking at, whichever one's your favorite, but also how they all get us to the same place. Most of them are just slight variations on the same principles, okay? And then there's a couple that are just basic, straightforward questions, and then there's a couple that, again, include some skills that you already have from other areas of mathematics. So this first one, how would you solve it? What do you notice about it? Does anybody, what would be your first step for solving a question like this? It doesn't matter what we start with here. So we're going to call this method 1. Alan, you had your hand up. What were you going to say?
First common factor.
Common factor. Very good. So it has a common factor of 4, and I'm left with x squared minus 25. How many people were thinking the same thing? And I said yesterday, you can just leave it like that. What's left is a difference of squares, so you would continue and factor that. And I said yesterday you could continue with that. Like you could just leave the 4 there, but today we're going to actually divide both sides by 4. The right side is 0, so 0 divided by 4 is still 0. That's why this works. If the right side was anything else, the 4 wouldn't magically disappear. Like if the right side was 12 divided by 4 is 3, so I would need to write 3, right? It doesn't just magically disappear, but it's 0 divided by 4, which is 0. Okay, and again, you can only do this in certain situations, like with equations when it's equal to 0. We can't magically start scratching out numbers and saying they're all gone. Okay, so I'm left with x squared minus 25 on the left. For example, I can't get rid of the 25 because I would add 25 to both sides. I would just move it to the other side. It wouldn't disappear. So you can't magically get rid of things. If you don't know why the 4 disappeared and you don't understand that, leave it there. Don't start magically getting rid of things. And what we're going to do with this is x plus 5, x minus 5 equals 0. And so then I get, therefore, x plus 5 equals 0, x x minus 5 equals 0, and x equals negative 5, x equals 5. Two solutions. So that's one way of doing it. Perfectly fine way of doing it. There's no better. Some of you are going to be like, obviously method 1 is the best way of doing it. Why would you do it any other way? And then somebody else is going to go, obviously method 3 is the best way. Why would you do it any other way, right? And it's not right or wrong. It's who you are, how you like to think, how you like to do these things. Okay, method 2. I'm going to run out of space. Oh boy. Let me pause for a minute and fix this so I have extra space. Copy. Paste. All right, we're good. Any questions about method 1? We're good? Oops. Sorry, I'm trying to make this look nice and it's not working. Oy. All right, there we go. Method 1. Method 2 is going to be very similar to method 1, and then method 3 is going to be quite different. What do I notice about the very first step? 4x squared minus 100. It is already a difference of squares. I don't have to common factor in this case. It is a good rule, always common factor first. It does make the math easier. Sometimes you can't keep going unless you common factor. But in this case, I can. So if you wanted to, like if to you it makes sense to skip a step and just do this, what would happen? Therefore, 2x plus 10 equals 0, 2x minus 10 equals 0, and I move the 10 over and divide by 2, and I move the 10 over and divide by 2. Negative 5, positive 5. Notice I got the exact same solution in both. One way when I divided out the 4 and I got rid of it, it made the end a little bit simpler. The other way I left the 4 in, so the factoring maybe is a bit harder, but it's easier at first or whatever and then harder at the end. I don't know. It's really the same thing, right? But interesting to note that in this case, works out the same. If you notice common factor or not, it'll work out. Last unit I said you have to common factor first because we didn't have equations. So if you didn't common factor first, then you never would, usually at least. And so in this case, because it's an equation, the common factor does tend to work itself out. Still a good habit to try to common factor first. Last thing I want to say is what's kind of another just interesting note. It may not be helpful, but when the thing that you start with is a perfect square or a difference of perfect squares, when you pull out a common factor, it will still be a difference of perfect squares like we saw here, right? So it's not like you're going to ever do it wrong and change the question and somehow it's going to be weird. If I had only factored out a 2, then I would have had problems because I would have had 2x squared minus 50, which is not a difference of perfect squares. Fully factor it, works out nicely. Oh.
If you square root them both and then put them in a bracket by the power of 2 on the top right side of it, and then equals 0, and then x.
No, you cannot do that. Absolutely not. Nope. Can't take the square root of a sum. So what Alan's asking is up at this step, 4x squared minus 100. Can you take the square root of both sides? No, we don't have a rule for square roots of sums. So that won't work. But there is something very similar to that that will work. That is method 3. So you can't do it that way, but you can do it this way. 4x squared minus 100 equals 0. Yesterday, when we first looked at how to solve quadratics, I said you can't isolate a quadratic in a quadratic because you have an x squared and an x term. And there's no way to isolate that way. That's even not entirely true, but it's complicated, so factoring's easier, right? But in this case, I only have x squared, I don't have the x. This is the case where the x part is gone. So in this case, you actually can isolate, and that's what I would call this method. I don't know if that's a formal name, but I would call this the type of question that you can solve by isolating. And this is what it would look like. 4x squared equals 100. And again, I could kind of do method 1, method 2. Like I could divide both sides by 4. Or I could just take the square root of both sides here. In this case, I'm going to divide both sides by 4. I'm not going to show the other way, but you could do it yourself if you wanted to. You'll notice they're all very similar. All the same numbers keep coming up. But some people like one method the best, some people like another method the best. And this ends up being x equals plus or minus the square root of 25, which is 5. Don't forget the plus minus. Because there are 2 answers. We've already shown that. And if you all of a sudden get only one answer, you've made a mistake. Like you've made the mistake. The process isn't the mistake, you made the mistake. This is fine if you write it this way. We did write it that other way, and it's a good habit, but this is fine this way. Okay, so still 2 answers. Got to it a different way. Solve by isolating. Solve by just a difference of squares. Common factor first, then difference of squares. It's not right or wrong. It's not one's better than the other. It's whatever's your favorite. That's how it works. Mahmood.
Are there any questions that will only be solvable with one of these methods? Or?
Yes. Good lead into B. Yes and no. Yes and no. What do you notice about B? Mahmood, do you notice anything about this one? It's a little bit different from the last one.
There's no square root for 40.
Yes, nice. 40 is not a perfect square. In this case, it's probably like, really 99% your best bet to solve by isolating. So I get x squared equals positive 40. Take the square root of both sides. And x equals plus or minus the square root of 40. And if this was a question where it was just like solve, give fully reduced exact answers, then I would have to continue this plus minus the square root of 4 times 10. That gives me 40. And x equals plus minus square root of 4 is 2. And then times the square root of 10. That would be like fully reduced exact answer. That being said, in this unit, most of what we do is going to be applications. So a decimal answer from this stage forward would probably be fine. Okay? There's no rule. It's just a matter of instructions, what the question asks you to do, what kind of a question it is. That's part of what we're going to do when we get into problem solving, is how should your answer look? Is decimals appropriate? Should it be exact answer? That's part of the process, is knowing that. Okay? Any questions about that? So in other words, when it's not a perfect square, factoring with the difference of squares is probably not your best bet. That being said, what if we tried? We're going to do a couple of little what ifs here. So I start with x squared minus 40 equals 0. What if I tried to factor this like a difference of squares? It's something plus something times something minus something equals 0. What's the first something? Square root of the first term. What's the second something? Square root of the second term. There's no rule that says you can't do that. Normally we do this, it would be 49. And square root of 49 is 7. There's no reason why I can't take the square root of other things and just call it the square root of that. This is a nice skill to have in mathematics. take the square root of anything and just leave it in that form. And this would, you don't have to write this down if you just want to watch. Therefore, x plus square root of 40 is 0, and x minus the square root of 40 is 0, and x equals negative root 40, and x equals positive root 40. So you get the same answers plus or minus the square root of 40 in a different way. I would not expect people to do it this way. Isolating is typically better in this situation. Bella. Hi. Yes. Yep. Yes. Sarah. Phone in the recycling bin for you. Alan.
That's the answer to x
Plus x equals plus minus 2 root 10. Yeah. Okay, another what if. You don't have to write this down. I told you this is a lot of like thinking today. Right? This is a lot of like asking questions like what if. So I'm going to change the question a little bit. What if it was x squared plus 40 equals 0? We'll just isolate. X squared equals negative 40. X equals plus or minus the square root of negative 40. What's going on here? Sakira. Can't take square root of a negative number. Therefore, no solution. Often we've had two answers to these quadratics. Sometimes you saw yesterday that there was only one answer to a question. You get two answers, but they're the same. Here's an example of a question where there are no answers. There's 0 solutions. But sometimes there's one solution, and sometimes there's two. What does that remind you of with quadratics? Something? It should. You're on the right track, yes. Anyway, it doesn't matter. We'll talk about this again after. Intercepts, that's right. Sometimes there's two, sometimes there's one, sometimes there's none. There's a direct relationship there. We'll talk about that after. Okay, so a few different things to think about there, but solve by isolating is a nice, easy way of doing it in that situation. Okay, moving on. You do want to write this one down. We'll kind of do two methods to solve this one, but again, they're very similar. This is not an isolating one. If you think it's isolating because there's two terms, you can move one to the other side. Oh my gosh, no. Don't ever do that. Only do that when it's the difference of squares, when you've got the constant. Minus 10x is not the same as minus 40. Very, very different. Okay, so this is the common factor type from yesterday, right? So let's just common factor it. Method 1 will just be common factor. X minus 5 equals 0. Therefore, 2x equals 0 and x minus 5 equals 0. Divide both sides by 2, x is 0 or x is 5. Method 2 is hardly different. It's hardly even a different method, right? But it's just, what if I pulled out the 2 first and divided both sides by 2? I end up with x squared minus 10x equals 0. Oh, sorry, 5x. And then I just common factor this. I could have done this in fewer steps. Absolutely, I could have done that. Like I kind of did it the long way, factoring out the 2 first, then factoring again. Like here, I could have, if I wanted, divided both sides by 2 and just gotten rid of that part and then solved. Again, I don't know why you would. Like some people are saying, why would you do that? Why not just go to the end? I don't know, but different people like to see it different ways. Okay, so there's different options, absolutely. That's your common factor type. Remember from yesterday, I said, think of the trinomial. This one's missing the constant term at the end. those ones that we started with are missing the middle term. So it's the isolating type. Missing the last term. So it's the common factor type. Keep that in mind. A few different ways to solve this one. Sure, right now. Okay, method 1. Whoops. These methods are going to be quite different. Method 1, square root of both sides. What's the square root of x minus 2 all squared? X minus 2. Square root of 49 plus or minus 7. Therefore, this is a little bit different from the ones we've seen. X minus 2 equals 7. X minus 2 equals negative 7, although it should be familiar slightly from something we did a while ago. Add 2 to both sides. Add 2 to both sides. And I've got 2 answers. That was pretty slick. Method 2. Again, if you don't fully understand every step of these, that's kind of okay. You only really need to know one of them, but it's important to think about it. If you want to go back and look at all these later, watch the video later, then you can and think about it more. It might help. What if this was written this way? So either method 2 is I move the 49 over. Okay, so subtract 49 equals 0. Or what if the question was given this way? This is like one of those tricky difference of squares questions from the previous unit, right? So what would that be? It would be something plus something, something minus something equals 0. Square root of the second thing is 7. Square root of the first thing, again, is x minus 2, x minus 2. X minus 2 plus 7 is x plus 5. X minus 2 minus 7 is x minus 9. Therefore, x plus 5 is 0, x minus 9 is 0, x is 9, x is negative 5. Same answer as above, different method. No reason to do one or the other. If you think Mr. Belair is out of his mind, why is he showing us harder ways of doing things? That's sometimes what math is about. To make the connections, we don't always just take the easy road. And as well, and this isn't necessarily true in this case, but sometimes the harder way is more versatile, so more useful down the road, and that's why we focus on it. Even if there's an easier way, sometimes that's not always the most efficient way down the road, right? But in this case, it's just more of a thinking exercise.
Method 3 and method 2. If you, let's say, if you use both of them, is there...
Okay, there is, first of all, I just want to make clear, these are not formal names for these things. So it's not like on a test I'll say, use method 3 for, there's nothing like that. I'm just randomly calling them method 1, 2, 3 in the order we're doing them. So, sorry, what were you going to ask though?
Let's say you memorize your log number 2 and
Sure.
3, all right?
Yeah.
Would you ever have a problem with it when we're working 2 and 3 and you have to use 1?
Not really, but never say never. For the most part, if there's one way that you like doing best, that'll kind of work for most questions. For example, the questions that we started with, isolating will kind of always work, whereas difference of squares is a little bit harder in some cases. And in this one, method 3 will always work and is maybe the simplest way. If you like it, it will always work. Method 1 and 2 should always work as well, but every case is a little bit different. So method 3, x minus 2 squared equals 49. I'm going to expand and simplify. X minus 2 equals 49. This is x squared minus 4x plus 4 minus 49 equals 0. Expand, simplify, move everything to the left. X squared minus 4x. 4 minus 49 is negative 45. Simple trinomial. Just go ahead and factor. X minus 9, x plus 5. Notice that that is exactly the same as what we got here. And so then the rest would look identical. So that could be a surefire method. If you don't like those other ones and you don't know when you can, when you can't, or you're just not comfortable, go ahead, expand and simplify. It's a little bit longer, a little bit more time consuming. Efficiency is useful, helpful, but in a pinch, expand and simplify will work. Any questions? Absolutely sure. That's the end of that part of the lesson where we're sort of thinking about different methods and different ways of doing things. Now we're just going to look at a few different examples. A couple of tricks that you might do in certain situations. What do you notice about this one? Jared. Everything's negative. What do we like? Or what do we not like about that? We don't like it when the leading coefficient on the x squared term, the coefficient there, is negative. We never factor like that. We don't want to factor like that. So I'm going to common factor that out. And it doesn't matter that the rest are negative. In this case, they're all going to become positive. But if they were positive, I'd flip them to negative, right? So you're dividing everything by negative 1. Now you might or might not decide to get rid of that negative sign out front. So I can divide both sides by negative 1 and get 9x squared plus 24x plus 16 is equal to 0. And I can do that because it's an equation, right? But so sometimes you can't do that, but in this case you can, so that's fine if you want to. Everybody good with that? That's kind of the trick to this one. Now it's just a complex trinomial factor. But you notice anything special about it? Yes, Jaden. It's a perfect square trinomial. How do you know that? Square root of 9, 3. Square root of 16, 4. 3 times 4 is 12 times 2 is 24. So it's a perfect square trinomial. So that means it's 3x plus 4 squared. Or 3x plus 4 times 3x plus 4. Therefore, you don't have to do this twice. Some people were asking yesterday, but I'm going to just, this one time kind of thing. So move the 4 over, becomes negative, and divide by 3. Move the 4 over, becomes negative, divide by 3. I get 2 answers, but they're the same. If you kept going in mathematics, you'd sort of learn that that's a little bit different from one answer, but it's sort of just a different way of thinking about it. But I got 2 answers, but they're the same. Earlier we were getting 2 answers and they were different. So really we only have 1 answer, but it came from 2 different places. Okay, next one. This is just a complex trinomial. So what are our factors? 1 and 7, 7 and 1, 1 and 4, 2 and 2. Go ahead and find the solution. Factor that. Anybody have the answer yet? There's a lot of people in the room right now thinking like, gosh, I thought I was good at this. Like, I thought I was finally getting factoring. I can't get the answer. There is no answer. This is not factorable. So it's not solvable yet. That question has an answer. We don't know how to find it. And we will learn later this week how to do so. It's with a different method. But it's not factorable. That is different from the question above, x squared equals negative 49, or x squared plus 49 or plus 40. That has no solution. That's different from this. That one has no solution. This one has a solution. We just can't find it by factoring. Okay, this is a real common factor. Go ahead and do it. It's not a trick. Let's get 2x minus 3, 4x minus 1. So move the 3 over. Positive 3 divide by 2. Move the 1 over. Positive 1 divide by 4. Everybody okay with this? Nothing really new there, just something to practice. Getting the answers as fractions is something you need to know how to do. Don't get 2 over 3, it's 3 over 2. Okay, 2 more examples. Solving quadratic equations with factoring. Our first step is very similar to solving linear equations, with fractions. Did I say factoring? Fractions. So a quadratic equation with fractions is going to be the same idea as any other equation with fractions. So what do? Who remembers? There's like a 3-phrase saying that I like that helps us solve these. Does anybody remember what it is? Or does anybody just think they know what to do? Anybody? What do you think?
Would you multiply the equation by 4?
Why 4?
Because you'll cancel out all the fractions and 2 times 4 is still 0.
Yeah. So find a common multiple of the denominators, multiply everything by that common multiple to get rid of the fractions. That's the way I like to think about it. You might think 8 because 4 times 2 is 8, and in this case that will work. But 4 makes it a little bit easier. So let's do 4. So 4 times x squared over 4 minus 4 times 3x over 2 plus, don't forget the 4 times 2, just because it's not a fraction doesn't mean you ignore it. And in a lot of cases, we've got 0 on one side, so it's 4 times 0, which is 0, but if it was something else, you have to multiply by 4. So if it was like a 1 over there, and in some cases there might be, you multiply that by 4. Wait till we're done. Okay. So how does this work? 4 divided by 4 is 1. 4 divided by 2 is 2. So this is x squared minus 2 times 3 is 6x plus 8 equals 0. Common factor x minus 2, x minus 4 equals 0. Therefore, x minus 2 equals 0. X minus 4 equals 0. X is 2, x is 4. Any questions about that? There's a bunch of questions in the homework with fractions, but you do them all the same way. We've already done this again. This is not new to quadratic equations. This is something you've done. We're just adding it in. Again, we're still always using the zero product property. Rip and Preet. Okay. What do you think you do in this one, the last example? Everybody should have a guess at how you would start this question. And then what would you do? Good guess, but no. There's a lot of x plus 3's and x stuff in there, so maybe, yeah. Alan, what do you think? Expand, simplify, move everything to one side, and then factor normally. Go for it. You try. Get x squared minus 7x plus 6. Don't stop there. Some people think that, now I'm done. Like even on the test, some people did this. All right, I'm done. No, we're supposed to be solving. Keep going. Factor that. And there you go. 6 and 1 are the answers.